Hi everyone, myself Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today my topic is Echelon form of a matrix. Okay, this is one of the method for finding the rank of a matrix. This is one of the method for finding the rank of a matrix. Already we discussed with the previous classes with the rank basic concept, and after that we will discuss about the same concept for finding the rank of a matrix by using echelon form. Okay, here what about the concept of the echelon form means a matrix is said to be in echelon form. It had the following properties. Okay, what's the first point of this? Zero rows if any occurs as the last rows. Zero rows if any occurs as the last rows. Second point, the number of zeros before the first non-zero element in any non-zero row is less than the number of such zeros in the next non-zero row. Okay, what about the first point of the echelon form? Okay, zero rows occurs as the last rows. Once you see the example for that, zero rows occurs as the last rows. And the second point, the number of zeros before the first non-zero element in any non-zero row is less than the number of such zeros in the next non-zero row. That means once observe here, first number of zeros before the first non-zero row is element in any non-zero row is less than the number of zeros. Here first observe in the first row 1 0, that is less than of the second row zeros, that is less than of the third zeros. If this condition is satisfied, there the given matrix is reduced as echelon form with respect to the only the row operations. Okay, this method is useful for finding the rank of a matrix. Okay, here simply the procedure for the echelon form is reduce the matrix as upper triangular. Reduce the matrix as upper triangular. Once see the example for this, here once observe what are the diagonal elements. Here the diagonal elements are this. Below the diagonals are completely zeros. Once observe, this example is for the rectangular matrix. For that any matrix, we have to reduce the matrix as upper triangular, okay, with respect to the only the row operations. For the rectangular matrix, we don't know exactly the diagonal elements. For that case, we can apply these two conditions. What about the first condition? Zero rows occurs as the last row, and the second condition, the number of zeros before the first non-zero element in any non-zero row is less than the number of such zeros in the next non-zero row. Okay, these two conditions applicable for the exactly for the rectangular matrix. For the square matrix means simply reduce the matrix as upper triangular with respect to the row operations. Okay, after reducing as the matrix as echelon form, the number of non-zero rows, then the number of non-zero rows is equal to the rank of a matrix. Number of here once you see the example, after reducing as this as in echelon form, here number of zeros less than of the next non-zero rows and less than of the next row zeros. Okay, here the condition is satisfied and completed. The last row is completely zero. Okay, then the matrix is reduced as echelon form. And here number of non-zero rows, how many? Once you see here, these are not completely non-zeros. Okay, this is completely 1 2 3 are there. That means what's the meaning of this? This is one non-zero row. One non-zero row. And what about the second row? This is also one non-zero row. And what about the third one? This is completely zero row. This is completely zero row. Therefore, how to define the rank after reducing as echelon form? Number of non-zero rows. Here how many are there? 1 plus 1, 2. Therefore, rank of a matrix is 2. Okay, this is the concept of echelon form. Once again, I'll repeat. Simply reduce the matrix as upper triangular with respect to the row operations. That's the concept of the echelon form. After getting the echelon form, number of non-zero rows, how many are there? We have to consider that as the rank of the matrix. Okay, I'll start with the problems. Okay. Here, before going through the problems, once you see that the number of non-zero rows in echelon form of a matrix has a rank of A. And one more important point, the rank of the transpose of a matrix is the same as that of the original matrix. After taking the transpose also, the given matrix rank is also same. Okay, na? Therefore, the rank of the transpose of a matrix is same as that of original matrix. Okay, first I'll start with the first question. Reduce the matrix to echelon form and find its rank. Reduce the matrix to echelon form and find its rank. Once you see that question here, matrix is -1, -3, 3, -1, 1, 1, -1, 0, 2, -5, 2, -3, -1, 1, 0, 1. Okay. What about the order of the matrix here? See, number of rows. 1, 2, 3, 4. 4. And number of columns. 4. Therefore, the given matrix is rectangular or square matrix. This is square matrix. Okay. For that, okay, reduce the matrix as upper triangular with respect to only the row operations. That is the given matrix. For reducing as upper triangular, first I'll make it as 1, 2, -1 are zeros. 1, 2, -1 are zeros with respect to R1. With respect to R1 first element, that is -1. For that, what about the row operation? That means what? First I'll make it as R2 first element, R3 first element and R4 first elements are zeros with respect to the R1 first element. For that, I am using the row operations. What about the first row operation there? See there, R2 tends to R2 plus R1. What about R2 first element 1 and R1 first element as -1? If you are adding these two, definitely R2 first element as 0. That operation is R2 tends to R2 plus R1. Similarly, third row, I'll make it as first element as 0 with respect to R1. For that case, I am using the row operation here. R3 tends to R3. 2 plus 2 into R1. R1 first element as -1. That is, R3 first element as 2 plus 2 into R1 first element as -1. That is, R3 tends to what? This is equal to 0. Therefore, this is 0. Okay. Next, not only the first elements, we have to use that row operation for the complete row. Okay. And for that R4 first element, and I'll make it as R4 first element as 0 with respect to the R1. For that case, I'm using the row operation R4 minus R1. That means -1 minus of -1. -1 plus 1 as 0. Then here directly R2 first element, R3 first element and R4 first elements are zeros. Not only you have to apply the operations on the first elements, we have to apply the row operations completely on the complete row. That means what? Here first row is R2 tends to R2 plus R1. That means here 1 minus 1 as 0 and the next one 1 minus 3. 1 minus 3 as -2 and next -1 plus 3 2 and next 0 minus 1 as -1. And similarly R3 row, R3 plus 2R1. That means first element as 0, okay, and next -5, -6, that is -11. And next 2 into 3, 6, 2 plus 6, that is 8. Okay, with respect to R3 operation. And next, what about the last element in the R3 row? That is -3, -2, that is -5. That is -3, -2, -5. I'm using that row, second row operation with respect to R1. Next, R4. I'll make it as R4 first element as 0. Already I explained. What about the remaining ones? Observe here. 1 minus of minus 3. 1 minus of minus 3 means what? That is 1 plus 3. That is equal to 4. Next 0 minus 3. That is minus 3. And next 1 minus of minus 1. That is 1 plus 1 as 2. Okay. With respect to R1, I'll make it as R2 first element, R3 first element, and R4 first elements are zeros. After that, before how we am taking this with respect to the diagonal elements, I'm reducing below the diagonals are zeros. That means what I'm using there, here I'm using minus 1. This is the first diagonal element in the first row. Okay, na? With respect to that, I make it as these 3 are zeros. Next, with respect to the next diagonal element, after getting this, what about the second diagonal element here? Minus 2. With respect to that, I'll make it as this, and these are zeros. Okay. For that, I am using the next two operations. That is R3 tends to 2R3 minus 11R2. R3 tends to 2R3. Here see, R2 second element as minus 2 and R3 second element as minus 11. I'll make it as this minus 11 as 0 with respect to R2, and similarly I'll make it as 4 as 0 with respect to R2 second element. Here R2 second element means indirectly that is equal to what? That is the diagonal element. Okay, na? With respect to the two operations, I'll make it as R3 second element and R4 second element are zeros, and there is no changes in the first row and the second row. For that, once you see that first operation, R3 tends to 2R3 minus 11R2. If you are using that, definitely that minus 11 as 0. This minus 11 as 0. And next, similarly, the next element, 2R3. What is 2R3 there? That is 2 into 8, 16 minus 6 into 11. Okay. 2 into 3 minus 11R2. From that, R3 element here 8 and R2 2. 8 minus 11 into 2. 16 minus 22. That is 16 minus 22 means how much? That is minus 6. Similarly, for that same 2R3. What about the R3 last element there? Minus 5 and minus 1. That is 2 into minus, once again, minus 5 minus 11 into minus 1. That is minus 10 plus 11. That is equal to what? Minus 10 plus 11 means that is equal to 1. Okay. With respect to R2, okay, I change the values in R3. That is, we get 0, 0, minus 6 and 1. Okay. And next, similarly, for the same row, with respect to R2, I'll make it as R4 elements are zeros. Okay. For that, I'm using the row operation. R4 tends to R4 plus 2R2. R4 tends to R4 plus 2R2. What about the R4 first element there? Directly 0, and R2 first element as 0. Therefore, first element is directly 0. And what about the R4 second element? 4 minus 4. That means 4 plus 2 into. What about R2? R4 tends to R4 plus 2R2. From that, R4 second element as 4 plus 2 into. What about R2 there in the previous matrix? That is 2. That means 2. That is 4 plus 4. 4 plus 4. That is minus there. That is 0. Here minus. That is 0. R4 minus 4 as 0. Similarly, third element. In the third element in R4, in the third element in R2. After using this directly, we get here 1. And similarly, R4 plus 2R2 for the last element here directly we get 0. Okay. Okay. If you are applying with the second diagonal element of the previous matrix, we get that these are completely zeros. And next possibility, okay, with respect to this minus 6, this is the diagonal element. With respect to that, I'll make it as 1 as 0. I'll make it as 1 as 0. For that, what about the row operation there? 6 into R4 plus R3. 6 into R4 plus R3. What is 6 into R4 is 1 minus 6. 6 minus 6 is equal to 0. And next, what about the last element? 6 into 0 plus 1, that is 1. Okay, here only I am applying the row operation on R4. Therefore, the remaining rows are same. There is no changes in that. Okay, therefore, the last matrix is here minus 1, minus 3, 3, minus 1, 0, minus 2, 2, minus 1, 0, 0, minus 6, 1, and 0, 0, 0, 1. Okay, is there any possibility to make it as this 1 as 0? No. Okay, why? Because if you are applying with this, okay, again we get here numbers. Okay, therefore, okay, once observe here below the diagonals are completely 0. Below the diagonals are completely 0. Therefore, this is an echelon form. Therefore, number of non-zero rows. How many here? This is one number of non-zero row, and this is one number of non-zero row, and this is one number of non-zero row, and this is one number of non-zero row. Therefore, number of non-zero rows, how many here? 4. Therefore, this is an echelon form. Number of non-zero rows are 4. Therefore, we have to consider that number of non-zero rows is equal to here rank of A. Okay, this is the first problem with echelon form. Okay, next example or next column. Find the rank of minus 1, 2, 1, 8, 2, 1, minus 1, 0, 3, 2, 1, 7. Once observe, is it rectangular matrix or square matrix? Here number of rows 3 and number of columns are 4. Therefore, it is a rectangular matrix. Previously, we discussed with the square matrix. Now I'll discuss with the same concept for the rectangular matrix. Same concept here. First I'll make it as 2 and 3 are zeros. 2 and 3 are zeros. For that I'm using the row operation. R2 tends to R2 plus 2R1. Next R3 tends to R3 plus 3R1. Okay, R2 I'll make it as R2 first element as 0 with respect to R1. For that 2 minus 1 into 2. 2 minus 2 as 0. And next similarly here 1 plus 2 into 2, 4. That means 5. Next minus 1 plus 2, that is 1. And next here 0 plus 16, that is 16. With respect to R1, then completely R2 row changed. And next again with respect to R1, I'll make it as R3 first element as 0 with respect to this operation. That is R3, I'll make it as R3 first element as 0. That means what's the row operation for that? R3 plus 3 into minus 1. R3 first element as 3 plus 3 into R1 first element as minus 1. 3 minus 3 is almost 0. Okay. Therefore, the first element as 0 with respect to R1. Similarly, 2 plus 2 into 3, 6. 2 plus 6 is 8. And next, 1 plus 3 into 1. 1 plus 3, 4. Next, 7 plus 8 into 3. 24. 24 plus 7, 31. Okay. With respect to R1, I'll make it as R2 first element and R3 first elements are zeros. Next, after that I'm using again one more row operation. Okay, with respect, after getting this, with respect to this 5. With respect to this 5, from the previous one, I'm using with respect to minus 1, that is R1 first element. Now I'm using R2 second element, that has 5. With respect to that, I'll make it as that 8 as 0. With respect to that, I'll make it as this 8 as 0. Then, what about the row operation for that? That is R3 tends to 5R3 minus 8R2. R3 tends to 5R3 minus 8R2. That means I make it as only the R3 second element as 0 with respect to R2. For that case, here what are the elements are there in that? R2 is 5. R2 second element as 5. R3 second element as 5. According to that, I am using the row operation. R3 tends to 5R3 minus 8R2. That is 5 into 8 minus 8 into 5. 40 minus 40, that is 0. Then that the first element, second element as 0 in R3 row. Similarly, next one, R3 first third element as 4, R3 third element as 4, and R2 third element as 1. Okay, from that, see there, 5 into R3, 5 fours are 20, 5 into 4 minus 8 into 1, 20 minus 8, that is 12. This is 12. This is 12. And similarly, in the previous matrix, 16 and 31. R2 is 16 and R3 is 31. That is 5 into 31 minus 8 into 60. After subtracting that, we get directly this is equal to 27. Okay, and then here once observe, okay, through the definition here, number of zeros less than of the next row zeros, here that condition is satisfied. And next, is there any possibility to make this 12 and 27 are zeros? No, there is no possibility. Okay, why? Because if you are applying with this, okay, again we get here numbers. Okay, and there is no possibility to make any value as 0 with respect to any row operation. Therefore, that stop the procedure. This is an echelon form and this is an echelon form. Here number of non-zero rows, how many? This is one number of non-zero row and this is one number of non-zero row and this is one number of non-zero row. Therefore, rank of A is equal to what? Number of non-zero rows. That is equal to how many here? 3. Therefore, okay, for the rectangular matrix, okay, for the rectangular matrix, what about the rank of that? That is equal to 3. Okay, this is the second problem. Next, similarly, third question, find the rank of a matrix by reducing it to echelon form. Here, what about the matrix? 2, 3, 7, 3 minus 2, 4, 1 minus 3 minus 1. For that, what about the matrix here? Okay, I'm using, okay, here one condition is there. If it is possible, we have to apply that condition for the echelon form. What about that condition here? First element, if 1 is there, we can apply with that 1. Or else once you have to observe, here in any row, first element is 1. We have to transform the values. We have to transform the rows. Okay, na? Here once observe, here in the third row, first element as 1. I'll interchange the rows. Okay, okay. If this condition is optional, this is not compulsory. If it is possible, we have to interchange. If 1 is not there, there no need for that. No need for that. Okay, here 1 is there. For that, I'm interchanging the rows. That is R1 to R3. That is after interchanging, this is the matrix. And next, for that, again, this is a square matrix. For that, I'm reducing. 3 and 2 are zeros with respect to R1 first element. For that, R2 tends to R2 minus 3, 1, and next row R3 tends to R3 minus 2R1. With respect to R1 only, I'll make it as R2 and R3 first elements are zeros. Here, what about R1 first element? Indirectly, that is diagonal element, first diagonal element, or else we can consider that as R1 first element. Okay, na? From that, here I'm using that R2 and R3. For that, okay, 1 minus 3 minus 1, and the next row with respect to R1, I'll make it as R2, that is 0, 7 and 7, and the next row 0, 9 and 9. Okay, na? After getting this is the matrix. Once observe, after getting this, here some common terms are there in that. What are the common terms in R2? That is, I'll completely, R2 is 7 and R3 as 9. I'll divide R2 matrix, R2 row with the 7 and R3 divides with the 9. That is 1 minus 3 minus 1 and 0, 1, 1 and 0, 1, 1. Okay. After getting this, is there any possibility to make this 1 as 0 with respect to the second diagonal element? Definitely. Okay. Then what about the rank? What about the row operation for that? That is, that row operation is here. Here R2, R3 tends to R3 minus R2. R3 minus R2. After that, this is 1 minus 3 minus 1 and 0, 1, 1. With respect to R2, I'll make it as R3 as 0, that is 0, 1 minus 1 0 and 1 minus 1 as zeros. Okay, this is the concept for the echelon. Okay, then they've completely here after applying the row operation with respect to R2, here R3 complete row as 0. Therefore, the number of non-zero rows, how many? Before going through that number of non-zero rows, is there any possibility to make R2 second and R1, R3 second and R2 third element as zeros? No. Therefore, there is no possibility to make any value as 0. Then we have to stop the procedure. Therefore, this is an echelon form. This is an echelon form. Once observe, below the diagonals are completely 0, including that diagonal element also 0. Therefore, here number of non-zero rows, how many? Number of non-zero rows 1, number of non-zero 1, and this is 0 row. Therefore, this is an echelon form. Number of non-zero rows, how many? Number of non-zero rows here 2. Here 2. Therefore, rank of the matrix there 2. Okay. Therefore, rank of the matrix is 2. Okay. This is the concept of the echelon form. Okay. Next class we will discuss with the same concept with the another method, that is normal form. Okay. Thank you. Thank you for all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.